Today we will be solving another LeetCode problem, and the problem we are solving is merge intervals. So in this problem we are given an array of intervals where an interval is denoted as a 1D array of size 2, and a particular interval is going to have a start and an end. So for example, this interval has start value as 1 and end value as 3, and start and end values are integers, so these can be negative as well. And we have to merge all these intervals and form an array of non-overlapping intervals that cover all the intervals in our given input. So first we are going to start discussing the brute force and then optimized version, and then finally we will be discussing a follow-up question asked in coding interviews. The follow-up question is, what if the given input is a stream of incoming intervals? And we will discuss that after covering the basics. So let's first discuss what does an overlap mean for two intervals, how two intervals can overlap. So let me draw two intervals here. So let's say this is interval 1 and this one is interval 2. So in this case we can see that 1 dot end value is greater than equal to 2 dot start value. And another way these two intervals can overlap would be if my second interval is here and my first interval is something like this. So for this case, 1 dot start value is less than equal to 2 dot end value. And let me draw two more intervals which do not overlap. So something like this. So let's say this is interval 1 and this is interval 2. So for this example you can see that 1 dot end value is less than equal to 2 dot start and 1 dot start is less than equal to 2 dot end. These two intervals do not overlap. When we are comparing two intervals, we'll have to do AND operation of these two conditions. If both of them are true, then only two intervals are going to overlap. So for this case, 1 dot end is greater than equal to 2 dot start, and also 1 dot start, this one, is less than equal to 2 dot end. And for our second pair of intervals, 1 dot start is less than equal to 2 dot end, and also 1 dot end here is greater than equal to 2 dot start. So both of these conditions are met in both of these pairs, and that is why these two pairs of intervals are overlapping with one another, and this pair specifically is not overlapping even though only one condition is true. So that is why both of these conditions must be true in order for two intervals to overlap. Now let's discuss the brute force approach. For brute force approach, let's have a look at this example. So here we are given these four intervals and we have to merge all of them and return an array of non-overlapping intervals. To understand the brute force approach, think of these elements coming in one by one. So for example, initially we only have this interval in the input, and then this input comes in and we process these two intervals, and after processing these two intervals, now our third interval comes, and when the fourth interval comes, we have already processed first three intervals and then process the fourth interval with the output of the first three intervals. So beginning with 1,3 interval, we simply add this interval to our output result. So we maintain a list of integer array and we simply add it to our result because this is the first interval. And now the second interval comes in, and now we have to merge this current interval with the intervals in our result list. So we iterate over our result list and see which intervals we can merge this 2,6 interval with. So currently we only have one interval in our result and these two intervals are overlapping. So after overlap, this is going to give us 1,6 interval. Since we are able to merge these two intervals, what we are going to do is we are going to remove this 1,3 from the result and add this 1,6. interval to our result. Now we move on to 7, 10 interval in the next iteration. 7, 10 does not overlap with the item in our result list, so we add this interval to our list. So now our result list has 1, 6 and 7, 10 intervals. So far it has 2 items. Now the next interval which comes in is 3, 9. Now again we are going to iterate over our result list and see how we can merge 3, 9 with the elements in our result list. First we check the overlap of 3, 9 with the first element. So yes, it overlaps, and the resulting overlap is going to be 1, 9. So the resulting overlap is simply going to be minimum value of the start values and maximum of end values. So the minimum of 1, 3 is 1 and max of 6, 9 is 9. So this is our resulting overlapped interval, and since this resulted in an overlap, we have to remove 1, 6 from our result list. Next we have to merge this 1, 9 with 7, 10, which is the next element of our result list. So 1, 9 overlaps with 7, 10, and the resulting interval is going to be 1, 10. So since this operation resulted in a merge, so we have to remove 7, 10 and add 1, 10. So finally we are left with only one interval, 1, 10, and our final non-overlapping interval is going to be 1, 10, and our final list will only have one element, which is 1, 10. Also, let's try to figure out the time complexity of this solution. Let's say at any point of time, this is the current state of our result list, and a new interval 7, 7 comes in, and this is just some interval I, and there could be more intervals after this. So what we are effectively doing is, for every interval we are iterating over the list. So this list can be bounded by O of n size, and when we are iterating over this list, it could take us O of n time. So for this example, what we are doing is, first we check if there is an overlap of 7, 7 with the first item. So there is no overlap. And then we check with 3, 4, there is no overlap. With 5, 6, there is no overlap. And finally there is an overlap with 7, 8. So what we do is, we first generate new start and end values, which would be 7, 8, and we remove this 7, 8 from our list. And finally, when we have iterated over all the items in our list, only then we add this new interval start and end to our final list. And this way the overall time complexity is going to be O of n square. And this will make more sense when I'm going to explain the coding implementation for this brute force approach. To come up with a simpler solution, we can sort these intervals based on their start times. So for this example, let's sort these intervals by their start times. So this is going to give us 1, 3, 2, 6, 3, 9, and 7, 10. If adjacent intervals are sorted by start times, then we can only check one condition for overlap. End time of the first interval is going to be greater than or equal to start time of the second interval. If that is the case, then there is an overlap. Now to come up with an algorithm to find non-overlapping intervals, what we can do is, again we can maintain a result list, and this is going to be list of integer arrays. And what we can do is, we can maintain two pointers. So the first pointer, let's call it current, and we start iteration over our given array, and we start from I equal to 1. So before entering in our for loop, we simply set current equal to the first element. And now what we do is, we set a particular ith interval to a variable. So let's call it interval. And now we check overlap of current and interval. If there is no overlap, then we can simply add our current interval to our result list, and this is going to give us a distinct non-overlapping interval. And if there is an overlap, then we can generate the overlapped interval and update our current variable with the updated values. So current is now going to be 1,6 since these two intervals overlap, and in our next iteration we set the interval variable to the next item. So our interval variable is going to point to the interval at index 2. And now we again compare these two intervals, current and interval. So 1,6 overlaps with 3,9, and this is going to give us a new interval 1,9. And since this is an overlap, our current variable is going to become 1,9 and interval is going to move to the next item. Now again we compare 1,9 and 7,10, and again there is an overlap, and this is going to give us 1,10. And now we have processed all of the intervals in our array, and we are left with current as 1,10. In the end, we add this current variable to our list and return this list by converting it to an array, and we will be done. Let's have a look at another example. So here we have this array of intervals, and this is already sorted based on start times. So following our algorithm, so this interval 1,3, this is going to be assigned to current variable, and our interval variable is going to be 5,7. So 1,3 is not overlapping with 5,7. So we're going to add 1,3 to our resulting list. So 1,3 will be added to our result, and now we move on. When there is no overlap, we simply set current equal to interval. So it's going to be current, and interval is going to be the next value. So 5,7 does not overlap with 8,8. So we simply add 5,7 to our result, and now we move on. So 8,8 is going to be our current interval, and 8,9 is going to be interval variable. So current is overlapping with interval, so the resulting interval is going to be 8,9, and we set current equal to 8,9, and now we move on to the next interval. Now we again compare this current variable with this interval variable, and now 8,9 does not overlap with 11,12. So we add 8,9 to our result, and now we set current equal to 11,12. And now we are done with our for loop, and after our for loop we simply add this current variable to our resulting list. So we add 11,12 to our resulting list. So these four intervals will be our final non-overlapping intervals, and this way we will be done. And this algorithm takes O of n log n time. So this n log n comes from the sorting, and after sorting we do O of n traversal, and overall this makes the time complexity as n log n, and the space complexity will depend on the sorting algorithm we are using, and generally it is log of n extra space. So n log n will be our time complexity, and space complexity will be log of n. Now one follow-up question that can be asked in an interview would be, what if the input intervals are coming as a stream of data? Now what this means is, currently we don't have any intervals. Now 1,3 comes in, and then 5,7 is coming, then 8,8 comes in, and so on. So basically we are receiving intervals one by one as a stream. So what can we do in that case? So initially let's say 1,3 interval comes in, and since this is the first interval, so the output is simply going to be 1,3. Now what happens if the next incoming interval is 5,7? So this 5,7 does not overlap with 1,3. So we can simply write 5,7. Now let's say one more interval comes in, which is, let's say, 11,12. So this also does not overlap with anything. So it's going to be simply 11,12. Now what if 6,9 interval comes in? So before processing this interval 6,9, what we can do is we can maintain the intervals processed so far sorted by their start times. So we have already maintained our intervals sorted by their start times. Now when 6,9 comes in, so this start time 6 is going to come in between 5 and 11. So first let me just write this 6,9 between 5,7 and 11,12. So this is going to be something like this. Now what could happen is this 6,9 can overlap with the left interval, and it can also overlap with right interval. And also there could be a case when there is no overlap. So basically there could be 4 cases. So first case, when there is no overlap and we simply add a new interval to our resulting list. Second case is when this interval is overlapping with the left interval. And third case is when it is overlapping with the right one. And fourth case is when it is overlapping with both of them. For the case when it is not overlapping, we can simply add that interval to our result. And in this particular case, it is overlapping with the left one. So we simply merge 6,9 with 5,7. And this is going to give us 5,9, 11,12, and we will be done. Now what if instead of 6,9 our incoming interval is, let's say, 6,13. If the incoming interval is 6,13 instead of 6,9, so what we can do is first we can check if this interval overlaps with the left one, and we can generate a new interval 5,13, and 11,12 would be here. And next we can check the output of this merge if this overlaps with the right interval. And yes, this overlaps, and this is going to give us a new interval 5,13. So our output intervals are going to be 1,3 and 5,13. One more thing that could happen is there could be more intervals which are to the right of 11,12, that is, which have higher start times than 11. So let's try to understand that case. Now let's say these are 5 intervals that we have processed so far, and now a new interval comes in, let's say 6,19, and now let's see what's going to happen. So the interval to the left of 6,19 is going to be 5,7. So we first simply merge 5,7 with 6,19, and this is going to give us a new interval 6,19. And the intervals to the right of 6,19 are now these 3 intervals. So we now process the first interval to the right of 6,19, which is 11,12, and we merge this, and this is going to give us 6,19. And now we are left with remaining 2 intervals, 13,17 and 20,21. So we also have to process intervals which have start times greater than 6, and not just the interval to the right of 6,19, which is 11,12. So the intervals which are to the right of 6,19 are these 2 ones. And as you can see, 6,19 can be merged with 13,17, and this is going to give us 6,19 as our merged interval. And now we are left with 20,21, and now 6,19 cannot be merged with 20,21, so we would be done. So to merge an incoming interval, first we try to merge it with the interval to the left of it, and then we try to merge that interval with the intervals to the right of it. So to the left of it, there is only going to be one interval, and to the right of it there can be more than one interval. So how we can implement this coding logic in n log n time? The data structure which can help us implement this in n log n time is going to be a tree map, which is a balanced binary search tree, and it uses a red-black tree. So what we are going to do is we're going to have a key value pairs. A key is going to be the start time and value is going to be the interval itself. So our intervals are going to look something like this: 5,7 and let's say 11 and 11,12. So currently we have these three intervals, and now when a new interval, let's say 6,9 comes in, so what we do next is we find floor value for this value 6 and a ceiling value for this value 6 in this tree map. So the floor value, which is just less than equal to 6, is this key 5, and the ceiling value, which is just greater than equal to 6, is this key 11. So we find these two values, and based on these values we get the intervals from the tree map. And once we are done processing intervals to the left and right, we simply add this new entry, which is going to be the new merged interval, to our tree map. So this is going to be some key, and we add that key value pair to our tree map. And also in the merge, if 5,7 gets merged, then we will have to remove this entry from the tree map. And in the case when 11,12 gets removed, we'll also have to remove this entry from our tree map, and we simply add the final merged interval to our tree map. This will be easier to understand when I explain the code for it. Now we have covered almost all the approaches for this problem, and now let's discuss the coding implementation of these approaches. Now let's try to understand the coding solution for our brute force approach. So as discussed from our coding implementation, that in our outer loop we have to iterate over our intervals. Here I have written the code already so that we can save some time in explaining the code, because I have covered the algorithm walkthrough in detail. So here, as you can see, I have defined a result list, and at the end we are converting it to an array, because the output of this function, it wants an integer array instead of this list. And here we have created a list because the resulting intervals, it can be dynamic. So we want something of variable size, and that's why we need a list. So initially we have this for loop which iterates over all the intervals, and it iterates over the interval such that when a particular interval, let's say first interval, comes in, we iterate over our result list. So we iterate over our list using this iterator here. So we define the iterator for our resulting list, and then we iterate over this list, and if there is a merge, then we remove that particular interval from our list, and we update the start and end values, and we keep going on to the next element till iterator dot has next is true. This means that there are further more elements in our resulting list. So let's say at a particular iteration, if there are, let's say, 4 intervals and one interval comes in, so the while loop is going to iterate 4 times, and we check if this particular interval is able to merge with any of these intervals. So let's say if it is able to merge with the first interval, then we remove that interval from our list and update the start and end values. And now when we remove it, the size of our list is going to be 3. And now the next element from it.next, it's going to be this interval, and then we check if there is an overlap. If there is no overlap, then we move on to the next one. And let's say if there is an overlap with this interval, then we remove it and update start and end values. And now let's say there is no overlap with this interval. Now this while loop is going to finish, and we are going to add our start and end interval, the final merged interval, to our resulting list. And now our resulting list is going to have 3 elements. And when we are done iterating over all the intervals, we simply convert this list to array and we would be done. So you might be thinking, can we avoid using this iterator? So let's say if we are iterating over our resulting list forwards, and let's say at a particular time there are 4 intervals in our list, and when we are at index 0, and let's say the interval at this index is going to result in a merge. Then we remove this interval, and what's going to happen is this list is going to rearrange itself into 3 intervals, and it's going to shift to the left. So what's going to happen is, if we are using a variable I starting at 0 to iterate over this list, then the interval at I equal to 0 would be this interval, which was at interval I equal to 1. This way our algorithm is going to break. So instead of iterating forwards, we should iterate backwards. So if we iterate backwards, our code will look something like this. So we start from the end of the list, and now if we remove an element at index I, then elements will shift to the left, but it's not going to break the ordering. That is, the interval which is at index I, it is going to remain at that index, and then it is going to work. So let's try to run this one. So this one works, which is great. And also let's try to run the previous code as well. So if I do Control Z and I come here, so I hit run, so that one works as well, which is great. And one more thing we can do, that instead of removing a particular interval from our list as we are iterating over the list, we can delay the removal after we finish our loop. So that would look something like this. So this is how the code would look like if we delay the removal from our resulting list. So we iterate over our resulting list. Now we are using some extra space, and for extra space we are using another list to maintain the list of intervals which should be removed. So instead of removing them from result, we simply add it to our toRemove list, and once we are done iterating over our resulting list, then we remove those intervals from our resulting list, and after that we add that interval to our resulting list. So this is the brute force approach that we can use, and we discussed 3 solutions. So now moving on, let's discuss one optimal solution that uses sorting by start times. This is our sorting solution. So what we are doing here is, initially we are just checking if interval's length is 0 or it is null. Then we are simply returning a 2D array with 0 rows, and if it is not 0 or null, then next we are sorting our intervals, and we are using the start value of the interval which is at index 0, and AB denotes 2 intervals, and we are comparing the start values of these two. And next, moving on, we define our final merged list, and at the end we convert this to an array. And as discussed from our algorithm walkthrough, we have to define 2 variables. So the first current variable will point to our first interval, and then we are going to start our iteration from index I equal to 1. And here I have used next variable to denote interval at index I, which is intervals I. So now we are basically comparing current and next if there is an overlap between current and next. Since the intervals are sorted based on start times, we can simply compare 2 adjacent intervals instead of comparing all the pairs. So here, if there is no overlap, this is the condition of no overlap. If end time of current is less than start time of next, so we simply add current to our merged list and we set current equal to next. And if there is an overlap, we set the end time of current as max of current 1 and next one. We don't need to set current 0 because it is sorted based on start times, so we can avoid that. And once we are done iterating over our for loop, we are going to add current to our merged list. We have to do this because when I is intervals length minus 1, that is I is at the last interval, current will be set in both if and else blocks, but it is not added to our resulting list, so we have to add it to our resulting list after our for loop. And at the end we convert our merged list to an array and we would be done. So let's try to run this one. So that one got accepted, and let's try to submit. So yeah, that one works, which is great. So this solution takes O of n log n time and log n space. And now let's see the optimization to our brute force solution using a tree map, where we assume that intervals are coming in as a stream of data. This is the coding implementation of our tree map approach. So here we have defined our tree map where the key is an integer and the value is the integer array, which is the interval, and this is our merge function. So since the intervals are coming in one by one as a stream of data, so what we are doing is we are iterating over intervals one by one, and as an interval is coming in, we call add interval function and add that interval to our tree map and do the required modifications. So for example, at a particular iteration, when a particular interval comes in, then initially we can check if start is greater than end, then that means it is an invalid interval. But for the problem constraints, we are given that start is less than equal to end, so we don't need to worry about this. And next, as discussed from our algorithm walkthrough, first we have to find the left entry in our map. So that is going to be the floor for this start value, and then we find that entry, and then we check if that left entry is overlapping with start and end interval. If that is overlapping, and then we update the start and end values and remove that entry from our tree map. And next we move on to the right entry of our start value. So this can be now the updated start value if this if block worked, and we can find the right entry by calling the ceiling value. And after we get the right entry, we have to process all the right entries which are to the right of start comma end interval, and we keep iterating over the right subtree as long as there is an overlap. So as long as there is an overlap, we update the end value and remove that entry from our tree map, and then update the right value as ceiling entry of start, so that we can move on to the next node in our binary search tree. And once we are done with overlapping the intervals to the right of start comma end, then finally we add that entry to our tree map, and then we would be done. And once we are done processing adding all the intervals to our tree map, we can call this function. So this function gives us all the intervals which can be generated by map.values. This map.values return type is a list, and we have to convert it to an array, and this way we can convert it to an integer array, and we would be done. So let's try to run this one. So that got accepted, and let's try to submit. So yeah, that works as well, which is great. So this is the coding implementation for our tree map approach, and overall time complexity is going to be n log n. If we do amortized analysis, then this add interval call is going to be log of n, and iterating over all the intervals is O of n. So n multiplied by log of n is going to give us n log n. You might be wondering that in the worst case scenario, this add interval call might take n log n, which is fine. And that is going to be the case when this while loop is going to merge all the intervals. So when this happens, then our size of tree, it gets reduced, and if we add all the summations, then it is going to be bounded by n log n and not n square log n, which is a common confusion. So I highly recommend you to do some mathematical calculations and mathematical proofs to understand this. And if you have any doubts, let me know in the comments. And thank you so much for watching, and I'll see you in the next video.